Hey everybody, today we're going to talk about partial variation. The last lesson we talked about direct variation, which if you will remember, had to do with a particular kind of linear relation, one where that line, when graphed, went through the origin. The origin is the point where the vertical and the horizontal axis meet, where the y, the vertical axis, and the x, the horizontal, oh sorry, other way around from your point of view, where the vertical axis, the y-axis, and the horizontal axis, which is often called the x-axis, where they meet. Um, and that is, and you know what, I have a feeling, well, that should be right for you guys. Um, anyways, it's the point where those two axes meet. The coordinates of that point are 0, 0, because we're at 0 on the horizontal axis and we're at 0 on the vertical axis, and a line would go right through that point. And we looked as well at the equations, or the model of the equations, the form of the equations that model um, direct variation relationships. And today we're going to look at this thing called partial variation, and there's going to be a lot of overlap, some similarity that you're going to see there. So without further ado, let's just get going on that. Once again, I'm trying yet another new piece of technology, trying to find something that's working well. This is actually the second video I've created for this lesson, but the first one just failed abysmally, so we're going to go ahead and give this a shot. And I'm going to switch over here. So you should be seeing kind of what my desktop is. If this works out, I'm going to eventually buy this app and we'll get rid of that Epic Cam ad on the bottom. But for the moment, we're just going to live with that. So this is a partial variation situation that we're talking about. So in terms of real world scenarios, um, this worksheet or this note sheet is asking you to consider the graph of a taxi which charges a $2 initial fare and then 50 cents for each kilometer driven. So if you've ever taken a taxi, you'll know that when you get into the cab, the driver turns on the meter, and before the taxi even moves away, before it's gone any distance whatsoever, there's money on the meter. There's an initial fare. It's kind of like an amount of money that you need to spend just to get in the cab. And then as the cab travels, as it drives along, then for every chunk of distance you go, more money gets added on. So here we're presuming there's a $2 initial fare and then 50 cents for each additional kilometer that you go. And this graph right here is supposed to represent that. We have cost on the vertical axis and we have distance on the horizontal axis. And if you remember, we say that the dependent variable gets graphed on the vertical axis and the independent variable gets graphed on the horizontal axis. Okay. All right. I had to pause there for a second. I'm back. So as mentioned, this is the graph of a taxi which charges a $2 initial fare and then 50 cents for each kilometer that is driven. And over here we have a table of values. You'll see that distance is in the left-hand column, and that makes sense because we said that distance, which is on the horizontal axis, is the independent variable. And we always graph the independent variable in the left-hand column. Okay, so let's fill in the cost here for a second. After we've gone 0 kilometers, we will still have a cost of $2 because we have a $2 initial fee. But as we go 1 kilometer along, we're going to have to add 50 cents for that because that's what it says in the description right here. So that's going to give us $2.50. And then we go another kilometer and there'll be another 50 cents, so that goes up to $3. And another kilometer still till we get to 3 kilometers, so we add another 50 cents, so we're at 350. And as you can see, it's increasing by 50 cents each time, so that's going to give us 4, and then 4.50. And if we were to graph all these values, essentially that's what we've done here. We've graphed all these values. You can see that when we've gone 0 kilometers, our cost is $2. That's why we have the line that represents this relation. It crosses the vertical axis, the cost axis right here. It doesn't cross it at the origin like it does if it's direct variation. Instead, it crosses it right here. And that is going to be a value on this axis of $2. Okay, I think in this graph, each grid is, we have 1, 2, 3, 4. So each grid is going to be 50 cents in this case. All right, so we're given the equation in this example, it's this right here. It's C is equal to 0.5D plus 2. Okay, so C is the cost, D is the distance driven, okay, in kilometers. C is the cost in dollars, by the way. And we're multiplying the D by 0.5. And that's because it's 50 cents per kilometer. Some number of somethings per something else. 0.5 is the number. The first something, some number of somethings is kilometers. It's the distance per, it's dollars, which is the cost per kilometer. And then we have this 2 over here, and my screen is frozen again. Let me give this a second. I think it's going fast. Here we go. So we have this 2 over here because we have a $2 initial fare. Okay, so C is the cost in dollars, and D is the distance driven in kilometers, and this is just not going well. I'll keep trying for a second here. So obviously my narration is out of whack here. So what's the dependent variable? Ask yourself that for a second. I've already said it actually, right? The dependent variable is the cost, which is the value C. Okay, hopefully I've solved that technical problem, but no guarantees. We'll see what's going on. So yes, the dependent variable, that was cost, and that's our represented by C in our equation, right? That's underlined in red right here. So the independent variable, you're not going to be surprised to learn, that's going to be the other one that we're talking about, and that is distance. And that independent variable is represented by the letter D. So if we think about what the general form of partial variation equations is, it's always going to look or be able to be rearranged into a form that looks like this. We have the dependent variable right here as the first thing. So in a normal XY graph situation, that would be Y, that's the vertical axis, is equal to some number. In this case, it's 0.5, okay? But the norm in the general form, the model that we use to represent these relations, is to use the letter M that's going to represent that number right there. And that's the coefficient of the independent variable. It's D in our particular example. It's what's on the horizontal axis, so we're going to represent that by X, because X is usually what the horizontal axis is. And then we have another value in here. It's a 2. That's the initial cost, right? That's the starting value. And that we represent by the letter B. It's actually, you'll see farther on down the page, Y equals mx plus B, right down here. Okay, so something to note here, this graph is linear like our previous graphs of direct variation. Okay, so they're both linear. But this question here, why is this graph not representative of direct variation? It's asking you to notice what's the big difference. And of course, the big difference here is that because this is, well, not because this is partial variation, it is partial variation. And the big difference between that and direct variation in terms of its graphing is that the line that represents the relationship goes through some spot on the vertical axis other than 0, other than the origin. So it does not go through the origin, okay? So this is an example of partial variation, okay? Part of the relation varies, that's the D, and part of it is fixed, that's the 2. It never changes, it's always 2. But the value of D is going to change whether you go, depending upon whether you go 1 kilometer or 5 kilometers or 500, okay? And this number right here, that's the rate, isn't it? That's the rate per kilometer. And looking ahead, that's really the number that ends up being the slope when we're talking about linear algebra. Okay, so equations of partial variation are represented by this model. We saw it just a second ago. Y equals mx plus b. It's what my fingers are pointing at right now, okay? And the y is obviously on the vertical axis. It matches up to, or it corresponds with excuse me, the C in our particular example. So this is the general form right here. This is a particular example of that general form. And you can see that the B right here, that's the fixed cost, okay? It's a 2 in our particular, it's a 2 in our particular example, right? And you'll notice that this line crosses the vertical axis at a value of 2, doesn't it? So it's no coincidence that the thing in this position, the fixed cost, is the place where the line crosses the vertical axis. It's 2. And of course, the M, I'll use a different color here just to emphasize that a bit. Oh, I lost, oh, here's my red pen. Okay, the M, that's our rate, okay, and the X, that is our independent variable, okay. So M is what's known, we called this the constant of variation. I think we called it that when we talked about direct variation in the last lesson, okay. So M is the constant of variation, it's the rate, 50 cents per kilometer, that is a rate. And B is the starting value of Y, okay, it's the initial value. So one thing to note, okay, is that, and you can always use this to spot a situation that's partial variation when you have access to the graph or when you can graph it, is that it never goes to the origin, okay? It begins at some point on the y-axis. So in this kind of rough example right here, there's your y-axis, there's your x-axis, sorry, it's a lot of focus, okay? And the line that we're drawing, it doesn't go through the origin down here. Instead, it crosses the vertical axis at some point up here, okay? And by the way, just to point out to you, in case you're not familiar with this, so this point where the two axes meet, there has coordinates, and those coordinates are 0, 0, okay? The first number here, always in a set of coordinates, represents where you are on the horizontal axis. So we're at 0 on the horizontal axis, okay? And the second number in a pair of coordinates, in an ordered pair, represents where you are on the y-axis. So if I had a point that was, say, over here, okay, and let me just draw an arrow so we know we're looking at that one. Okay, if I had another point over here on the x-axis, well, this number for this point could not be 0 anymore because I'm no longer at 0 on the horizontal axis. So I know the focus is changing here, by the way, so please bear with me. What did I want to say? Yes, so the value of this point here, I don't know what it is. It's definitely not 0. So I'm going to make up a value. I'm going to call it like 2. Okay, but I do know that the y-coordinate has to be 0 because we are not any place up on the y-axis here. We're right on the x-axis itself, and the y value has to be 0 at that point. Okay, and that's all I want to say at the moment for this. So let's flip the page over. Okay, let's do a couple of examples fairly quickly. So the cost of printing a yearbook, okay, is made up of two things. There's a fixed cost of $1,800 right here, okay, and we seem to be frozen again. There we go, we've caught up. So there's a fixed cost of $1,800 and then a $10 per book charge, $10 for every book that's ordered afterwards. So the $10 per book, that's a rate. Anytime you see the word per in there, some number of somethings per something, we're talking about a rate, okay? And then we have an $1,800 fixed cost. So the first question we ask is, why is there a fixed cost? Well, let's answer that down here for a second. Let me go down here. Why is there a fixed cost? Ask yourself that for a second. Ponder it for a moment. The answer is that there's a fixed cost because even if one book is printed, you have to set up the whole printing press. There's a whole bunch of upfront investment that has to happen in order for any books to get printed whatsoever. So printers will charge you a setup fee, which is the initial cost, okay? So that's, what are we going to say here? Let's just say it's the initial setup fee. Okay, it's the initial setup fee. Okay. Let's make a table of values. Part B is asking us to make a table of values for 0, 100, 200, 300, and 400 books, okay? So when 0 books have been sold, what will our cost be? I'm pausing to let you think about that for a second. Pause the video if you want. If you said that the cost when there are 0 books sold is $1,800, you are correct, right? Because that's our fixed cost. You can always, we'll work with that in a second, sorry, excuse me. Let me backtrack on that for 1 second. So anyways, 0 books sold cost $1,800, right? If we sell 100 books, well, it's $10 per book. So 100 books at $10 per book is 100 times 10. That's 1,000. So we have to add that $1,000 on to the initial 1,800. So that's going to give us 2,800. And then we're adding another 100 books. So that's going to be another, because we're going from 100 to 200. Okay. So that's going to give us another $1,000, and that's going to bring us up to 3,800. And going from 200 to 300 is yet another 100 books. So that's another $1,000. So we're at 4,800, and one more $1,000 brings us up to $5,800. So here we've done part B. So question C, or part C, asks us to graph our results, okay? And what are the independent and dependent variables? So ask yourself for a second, what is the independent variable? In other words, which variable is going to go on the horizontal axis? If you answered number of books, you are correct. Okay. We also know that because we're looking at the table of values, and the left-hand column in the table of values is the number of books. Okay. Then by process of elimination, the cost is what's going to be on the vertical axis, and the cost is our dependent variable. Okay, this grid really isn't big enough to get all these values on here. I want to use each grid square here to represent $200. Okay, sorry, not $200, to represent $200. So that means we're going to have 200, 400, 600, 800. That's going to be 1,000. Okay, and then 5 more, 1, 2, 3, 4, 5. That's going to bring us to 2,000. And then 5 more after that, 1, 2, 3, 4, 5, is going to bring us to 3,000. And 1, 2, 3, 4, 5. That's going to bring us to 4,000. I'm not going to write it because it's going to go right over the dollar sign. And let's just graph our values here. So we're going to have, oh, and number of books. Let's use 2 horizontal grid squares to represent each 100 books. So that's going to be 100, 200, 2 more grid squares will give us 300, and 2 more after that will give us 400, and that's as far as we're going for this graph. So when 0 books have been sold, in other words, we're at 0 on the horizontal axis, we are going to be at $1,800 in cost, which will be that point right there. And when we have sold 100 books, where my finger's tapping right now, we will be at 2,800. So we're going to be at that point right here, 100 on the x-axis and 2,800 on the on the vertical. And then when we go to 200, we're going to get as far as 3,800, which is going to bring us right there. And because this is not a great grid, that's as far as we can go. But there's 3 points, that's enough to graph the line. So let's mark that in. Okay, let's give it a title, because all our graphs are going to need a title. So we'll go, let's call this cost per number of books sold. Cost per number of books sold. Okay. So that's part C that we've done right here. So D, we need to write an equation that represents this relation. Well, remember, so let's just mark it down right here. So C. The general form of the equation is always y equals mx plus b. And y is going to be our dependent variable. So in this case, our dependent variable is the cost. So let's represent that by the letter c. And then an equals sign. Okay? And then m is the rate. M is the number that the independent variable is multiplied by. So let's just write down the independent variable for a sec, okay? Let's just get that out of our brains. So number of books. So let's represent that as n. Okay, so that's going to be the number of books. We're going to represent that by n. And the coefficient of that variable is going to be the rate. It's $10 per book. So that's going to be 10n. Okay, $10 for every one book that we sell. And then there's an initial fee, which is, ask yourself for a second what it is, anticipate. Yes, it's 1,800. So there's the equation. Okay, and I wrote that down. That's not C, that is D right here. That's part D that we're answering. Okay, what do we notice about the location of the fixed cost? That's what E is asking us. Well, it's where the line intercepts the y-axis, right? At that value, 1,800. It's where the line intercepts. To intercept means to cross. I'm going to say the vertical axis. Let's just be a little more general. So it's where the line intercepts the vertical axis. That's E. F. F asks us to use the equation to find out how much it will cost to order 540 yearbooks. So our equation is C equals 10n plus 1,800. And we're going to substitute 540 for what? Which variable are we going to replace with 540? Is it going to be the C or is it going to be the N? It's going to be N because it's 540 yearbooks that we are substituting, and N represents the number of books. So let's plug that into our equation. We're asked to calculate the cost. That's actually what the question says. How much will it cost? So clearly that's going to be our unknown. Equals 10 times 540 plus 1,800. So that's going to be C is equal to 5,400 plus 1,800, because 10 times 540 is 5,400. And that's going to be a total of, I think it's 7,200. My brain is not working very well. Yes, it's 7,200. Okay, so the cost will be 7,200. Don't forget, word problems need concluding statements. And don't forget the units, $7,200. And then the last question is G. Okay, we're going to use the equation to find out how many yearbooks can be ordered for $5,050. That's what the question for G is. So once again, our equation is C is equal to 10n plus 1,800. We're going to sub the value we're given, which is 5,050, and we're going to substitute it. Well, are we substituting it for C or N? Well, it's $5,050. C represents the cost in dollars, so we're going to substitute it for C. And we're being asked to find N, right? So that's going to be 5,050. We're replacing the C with the 5,050. That's going to be equal to 10n plus 1,800. Let's move the 1,800 over to the left-hand side so we can isolate 10n. Don't forget, when you move the 1,800 over the left-hand side, you have to change its sign. So it's going to be negative 1,800, and that's going to be equal to 10n. Sorry, I'm taking my hand away so that the camera has a chance to focus again. Okay, 5,050 minus 1,800 is 3,250. That's equal to 10n. And we're going to divide both sides by 10 in order to isolate the n. 10 over 10 is the same as 1, so they just cancel out. And we get n is equal to 3250 over 10. So n will be equal to 325. 325 books is the number of books we can order for $5,050. So we just need a concluding statement. So you can order 325 books. 325 books. So as you can see, there's some homework to do down here, page 250 in the text. Questions 1, 2, 3, 4, and 5. If it asks you to graph, I can't remember right off the top of my head, if it asks you to graph, you can just do sketch graphs, okay? Or you can do ones like this if you have graph paper. So the main purpose is just to understand, generally speaking, what's going on graphically. As always, oh, here, let me switch back to face mode for a second where we are here. So as always, if you have any questions, please don't hesitate to ask. Pop off an email. I'm being fairly good about getting back to people fairly quickly. It'll be, at most, it'll be 24 hours, and it'll probably be less than that. So give me a shout if you have anything. If we need to do a one-on-one video chat, we can do that too. So I hope you're all taking care, and I'm looking forward to connecting with you guys soon. Bye.